Hello and welcome back to College Algebra. This is section 4.1 and this is the beginning of the material that will be on test 4. So this is the last test material. So start off by reminding you, letting you know, you've probably been looking at the calendar, that homework and quiz number 10 are just covering section 4.1, which is the section that's on this video. It will open Wednesday, April the 1st, and it will be due on Thursday, April the 9th at 11:59 p.m. Please keep in mind, it was brought to my attention that not everybody's running on Central Time, but all of these due times are based on Central Time. So please keep that in mind and adjust your schedule accordingly, or at least make note of that so that you're looking at 11:59 p.m. Central Time for the due times on this. So hopefully everybody is doing well with their material, attending some WebEx sessions maybe, or just emailing me and asking questions. Hopefully you're doing your weekly check-in quiz and everybody has successfully loaded the lockdown browser by now because, well, you should by now. All right. Let's get started with section 4.1. This is the only section in chapter 4 that we do in this course, and a lot of it is kind of repetitive because we've been talking about quadratic equations and we've been talking lots and lots about functions. So we're going to specifically talk about quadratic functions. You know that I think these things are fabulously fun. So and I really in reality, this is probably my favorite section to teach. So I'm sorry I don't get to interact with you guys. But hopefully you'll enjoy this video lecture. All right, so we have two different forms of our quadratic function. We have what's called the standard form of our quadratic function, which allows us to really kind of pull out the vertex or the turning point. We talked a little bit about that vertex or that turning point when we were talking about transformations of functions, and also just when we've been graphing these functions in general. So when I look at transformations, this H is my side to side or my left and right movement, and the K is my vertical or my up and down movement. And so if I were to shift X squared, H units to the, in this case since it's minus, to the right, so we keep this sign in here and we keep this sign, we change this sign in here and we keep this sign out here, then our vertex would be positive H and positive K. And so we would actually shift that around. So we're going to kind of explore that in terms of the vertex also. Couple of things in a quadratic function, we do have what's called an axis of symmetry. Now the axis is always an equation. So this is going to be an equation and it's actually going to be a vertical line. So it's the equation of a vertical line. And it's the equation of a vertical line where the graph is symmetric about. So if I were to sketch just kind of the general quadratic function, it looks something like this. And so as I come here and then it goes up, so it is actually symmetric about this y-axis. Okay, so you know my graph's not very good, but you get the idea. So this axis of symmetry is always a vertical line and it's always x is equal to, and it's the x part of the vertex. So this h here and this h here are always the same, but you do have to type it in as x equals to that number. Okay. If A, the number in front of my parentheses here, is positive, that means that the graph opens up. And remember, we talked about relative maximums and relative minimums back in the section on graphing the functions. We talked about properties of functions. If it opens up, then its turning point is going to be a maximum. If the function opens down, because we have this little negative in front of everything, which flips it all upside down, then my turning point is a maximum. So opens up, the turning point's on the bottom and is a minimum. Opens down, the turning point's on the top and is a maximum. Everything on the bottom of this slide is exactly the same as it is on the top of the slide, with the exception of how we find the vertex. So this is what we call our standard form. This is what we call our general form. Now this could also be, we don't have to use y, we could use f of x here. And the same thing is true here. This could be f of x is equal to something times x squared plus something x plus something. So the catch is we do have to have the x squared term. But in order to find the vertex, we could do some messy stuff and put it into this form. But the easy thing to do is to learn this little formula. So the h part of my vertex, or the x-coordinate for my vertex, is negative b over 2 times a. To find the y part, or the k part, we're literally going to plug this value in for x, okay? So the k part of the vertex is to find f of h. So let x be equal to whatever we find here, and we'll find that value. We're going to do several of these, so you're going to get really good at this. Axis of symmetry is still x is equal to h. It's just that h is in the form of negative b over 2a. Same thing down here. I'm going to scroll this down so you can see what's going on. Might have to move my screen just a little bit. There we go. So if a is positive, then the function opens up and has a minimum. If it's negative, the function opens down as has a maximum. Same thing. It's just that the a is directly here in front of the x squared, whereas in our standard form, it's out here in front of the parentheses. But we got this. We're going to see lots of examples. Okay, so one other thing when we talk about these quadratic functions, we do talk about the vertex. That's nothing new and strange. This is just another picture of this, giving you an example of that axis of symmetry. It always passes through the vertex, and so you have this nice symmetrical shape on either side. But just to remind you, once again, a picture to let you see, if it opens up, my vertex is on the bottom down here. It's going to be this minimum point, and that's going to be significant for our range. If it opens down, it's up here on the top, and so my vertex is this maximum. Notice it doesn't change the domain, but it does affect the range, all right? So if my function has a minimum value, then the range has a starting place and it goes to infinity. If my function has a maximum value, the range has negative infinity to a stopping place. So minimum, it has a starting place. Remember, the range is your y values. Maximum, it has an ending place. It has a maximum value, all right? And notice that this k is always going to come from the k part of your vertex. So this k and whatever your range ends at are the same thing, okay? All right, I really love that illustration, and so I wanted to share that with you guys. So first things first, without graphing, so we don't want to sketch a graph of this, we just simply want to look at the function and determine whether or not the graph of each quadratic function opens up or down. It's quadratic because the highest power is x squared. What do we look at to determine whether it opens up or down? Correct. We look at this value of a. So a is the number in front of x squared. A is negative 2. That means that it is a negative value. And if a is negative, then that means that my graph opens. Hopefully you've written this down by now. The graph opens down. You got it. So it's going to open down. Okay? All right, that's all we want to do on this one. So for problem number 2, once again, we need to determine if it opens up or opens down. So we go through our function. We see this x squared term. That's always what we're looking for, is the x squared term and the number in front of x squared. So a has a value of positive 5. It is positive, and since it is positive, then that means that the graph of this function opens. Yep, you got it, up. Very good. Okay, that's all we want to do for problems 1 and 2. Okay, you got this. Okay, so now we're going to take several steps here. There's actually parts A through G, and we'll kind of scroll down so you can see that G. G is just asking us to state the domain and range in interval notation. We've already graphed, so we will have already graphed. So the first thing we want to do is find the vertex. This function is in what we call that standard form. So if you want to make a note of this, this one is in standard form. So it doesn't ask you that, but I'm just telling you that for your information. The vertex is where did it get shifted to horizontally. Remember, this negative means it shifted to the right 2 units. So if we shift it to the right 2 units, we have an x value of 2, and we shifted it down 4. And so the vertex is 2, negative 4. You can either simply do this by changing the sign inside and keeping the sign outside, or you can think about it in terms of the transformation of functions, which was in section 3.4. Okay, all right, so the next part of this says, does the graph open up or down? And how do we determine whether it opens up or down? We look at the number in front of the parentheses. So in this particular problem, our value of A is 1. It's this understood 1 right here. Since it's 1, that means it's positive, and so therefore the graph will open up. Yep, you got it. Okay. What is the equation of the axis of symmetry? Now start off by remembering that the axis of symmetry is an equation, and so it has to be x equals, you can't just give me a number. If you put a number in, it will be wrong. So x is equal to, and we go to the x part of my vertex, so x equals 2 is the axis of symmetry. Make sure that you write the equation, okay? All right, x-intercepts are the zeros of the function. Now, if you recall, we talked about x-intercepts and we talked about zeros back in chapter 3. The x-intercepts and the zeros are the same. To find the x-intercepts, do you remember what we do? That's right, we let y be equal to 0, or the function be equal to 0. So in this case, we're going to take the entire function, x minus 2 squared minus 4, and we're going to set this equal to 0 and solve for x. So the first thing I'm going to do is I'm going to add 4 to both sides, so I get x squared is equal to 4. This is going to lead me to x minus 2 is equal to plus or minus the square root of 4, because we take the square root of both sides. This I'm going to break into one more line here. This is going to be plus or minus 2. And so now I'm going to separate this into two equations. So I have x minus 2 is equal to positive 2, and I have x minus 2 is equal to negative 2. So if I add 2 to both sides, I get x is equal to 4. And if I add 2 to both sides here, I get x is equal to 0. So my x-intercepts, or my zeros of the function, if you are asked to list them, it would be 0 and 4. If you're asked for ordered pairs, so be careful, pay attention to what it's asking you for. The ordered pair is 0, 0, and the other ordered pair is 4, 0. We know what the x values are, and we picked the y value, okay? And sometimes this is kind of nice because it might help us out just a little bit. The next part says find the y-intercept. To find the y-intercept, we're going to let x be equal to 0, and that means in terms of our function, we're going to find f of 0. And so this is going to be 0 minus 2 squared minus 4. So 0 minus 2 squared is 4, and 4 minus 4 is 0. So you might have kind of seen this coming, so the y-intercept is at 0, 0 also. So for future reference, if we have an x-intercept of 0, 0, that is also going to be our y-intercept, okay? All right, so now it says sketch the graph using the vertex and the intercepts. So we're going to plot these points that we have here. We have the point 0, 0, and we have the point 4, 0, and our vertex better fall somewhere in between, and it does, and it's at the point 2, negative 4. And you guys know that my graphs are not super great, but we're going to do the best we can. And we're going to sketch it here, and we're going to sketch it here, and there is my graph, right? So from this, and hopefully we'll figure out how to do this without the graph also, but the domain of this function, because it is a polynomial function, is negative infinity to positive infinity. The range for this function, it has a minimum value because it opens up, so that means the range has a starting point, and it is the starting point of negative 4 right here, and it goes to positive infinity because remember the range is the y values. Excellent, very good. Okay, let's move on to the next one. So now we have another quadratic function. We're going to do the same things exactly for every single part of this. My quadratic function is negative, and then we've got, it's out here, we've got x plus 1 squared minus 2. Notice this negative here. Okay, the negative does not affect the vertex. The vertex plus 1 tells me that it moved 1 unit to the left. That's correct, or the opposite of 1. And then 2 units down. So here is the ordered pair for my vertex, negative 1, negative 2. The next part says, does the graph open up or down? What do we look at to determine if it opens up or down? I'm going to highlight this for you right here. There's the value I'm looking at, and so A has a value of -1, and this means because it's negative that it opens downward. Okay. All right. The axis of symmetry should be just like the nicest problem in the whole set. It is always that equation x equals 2, and we go to the x part of the vertex, and so x is equal to -1, and that is my equation of the axis of symmetry. All right, to find the x-intercepts or the zeros, again, we're going to let y be equal to 0. So if y is equal to 0 or the function is equal to 0, I'm going to take my function negative x plus 1 squared minus 2, set this equal to 0, add 2 to both sides, and I'm going to get negative x plus 1 squared is equal to 2. Divide both sides by -1, and I get x plus 1 squared is equal to -2. Now, some of you might not have caught this, and some of you have caught this as something squared cannot be equal to a negative. So in this case, we have no x-intercepts. And we're going to verify that with the graph in just a second. I'm going to show you how to do that. Okay, so we want to go ahead and look and see if we can find the y-intercept. There's only going to be one of them. So for the y-intercept, we're going to let x be equal to 0. So we're going to find f of 0. So we go to our function. It's a negative, and then 0 plus 1 squared minus 2. This is going to give us -1 minus 2, which gives me a value of -3. So my y-intercept has a value of -3, or it can be written as the ordered pair 0, -3. Okay, so we get ready to sketch the graph. We only have now 2 points to sketch. We have the point -1, -2. There's our turning point or our vertex. And then the other point we have is at 0, -3. Remember, the function opens down. If it opens down, it goes like this, and I'm going to draw it in a second. Where does it cross the x-axis? Well, it does not cross the x-axis, and that is why when we looked for our x-intercepts or our zeros of the function, we found that it didn't have any. Okay, so you kind of verified that by looking. Sometimes if you get this, you look at the vertex and go, okay, below the x-axis opens down. Oh, it's not going to have any zeros, and that's perfectly fine. Okay, so the domain is still -infinity to +infinity. That's kind of boring on these because it is a polynomial. The range, however, now has a maximum value, and so the range is going to go from -infinity to that maximum value, which is -2. Exactly, the y part of my vertex. Excellent, very good. Let's see what other fun things we can run across. Number 5. This one is not in standard form. It is in our general form that I mentioned. So in order to find the vertex of this, we're going to have to use that little formula that I told you. So h is equal to -b over 2a, where b in this case is +6, and a in this problem is +3. Okay. So if you want to come over here to the side, a has a value of 6, sorry about that. A has a value of 3, and b has a value of 6. And so now we're going to clean this up. 6 divided by 6 is 1. So my vertex is going to be the ordered pair 1 something. Well, just like I told you, it is a point on the graph of this function. So to find the y part, we're going to have to plug in the x value of 1 in this case into the function. So I have 3 times 1 squared, and I have plus 6 times 1 minus 4. And so I'm going to have 9 minus 4, and so I'm going to get a y value of 5. So my vertex of 1, -5 is going to be the point that I'm going to graph. Now, is it going to be a maximum or a minimum? Well, we determine that by figuring out how the graph opens. So how do we determine if the graph opens up or down? You're right. We go to the number in front of x squared. So this one to me is a little bit easier because it's sitting there right in front of x squared. So a has a value of 3, which is positive. And so since it's positive, it means that the graph of the function is going to open up. Okay. So axis of symmetry is exactly the same thing we did before. It's the equation x is equal to, and in this case, we go to the x part of the ordered pair, the vertex, and it's x is equal to 1. So our x-intercepts are our zeros. Again, we're going to take the function. So we have 3x squared plus 6x minus 4, and this is going to be equal to 0. So we might be a little bit intimidated by this because of this 3x. So, you guys who are sitting there going, I need to raise my hand, I need to raise my hand. Yeah, you should have raised your hand because I just realized that I made a really big goof up here. I was looking at these and I thought, that doesn't look right. So, we're going to go back and make a big correction up here. If y'all had been in class, y'all would have been yelling and screaming at me. So, let's go back up here. This is negative. I lost the negative up here, and this is going to make a really big difference. So, my negative 6, so this makes this negative 1. Okay, so yes, through the magic of television, I can do all kinds of erasing, and that's okay because it'll be on the video for everybody to see and go back and review. But we're going to fix this now. So my ordered pair is going to be negative 1. Still going to take this and plug this in for x in my original function. So I want to find f of negative 1. So 3 times negative 1 squared. I am so sorry. So this is what happens when I don't have feedback in the class and y'all are not all looking at me with funny faces. So this is going to be 3 minus 6 minus 4. Negative 3 minus 4 is going to be negative 7. So that's going to be a much nicer vertex. 1, 5 is a very lovely point on the graph of this function. It is just not the vertex. So anyway, okay, so this is going to be my vertex. Still opens up, doesn't change anything else. I just lost that negative sign. So sorry about that. Okay, so now let's go down here and find our intercepts. Now, as I was saying, you might be a little bit concerned because of this 3x squared. I would probably go ahead and plug this into the quadratic formula. And for a couple of reasons. One, it's a nice practice for the quadratic formula. And two, that 3 in front of the x squared disturbs so many people that I think it's just easier. Even if it does factor, then it'll come out to be a nice number when we plug it into the formula. So, okay, so let's start here. So we have x is equal to negative b, I'm not going to lose my negative sign this time, plus or minus the square root of b squared, so that's going to be 36, minus 4 times a times c, kind of squishing this in here, all over 2 times a, which we're going to have 6 down here, so negative 6 plus or minus the square root of, that looks like 84 when we put all that together, divided by 6. Now that does not simplify to a nice whole number. So we do have to work a little bit with this. So this is going to be negative 6 plus or minus. I can actually factor a 4 out of this, and so that's going to be 2 times the square root of 21 over 6. So this 84 will come over here. The square root of 84 factors into the square root of 4 and the square root of 21. And so the square root of 4 is 2. And then I'm left with that square root of 21. There's not a whole lot I can do about that. I can divide a 2 into all 3 of these pieces, and so this does simplify to negative 3 plus or minus the square root of 21 over 3. So those are not beautiful numbers. It's going to be okay. We don't have to have exact values, but we'll get a general idea. So the y-intercept is a lot nicer. So we want to find for the y-intercept, we want to find f of 0. So I'm going to plug 0 in for my x in this problem. And so 0, 0, and it looks like I'm going to get negative 4. So the y-intercept is negative 4, or we can write this as an ordered pair 0, negative 4. So let's go ahead and graph that 0, negative 4. And that's why when I knew that was going to happen, that's why I knew that I'd messed the other one up. Sorry about that. So negative 1, negative 7. And if we wanted to graph 1, 5, we would be way up here, okay? Now, this is going to cross the x-axis. It is going to have intercepts. It's going to be kind of a narrow little skinny graph here, and it's going to come down somewhere That was not pretty. So let's try that again. It's going to come down somewhere through this point and down here. Oh, my graphs are just terrible. And then it's going to go back up somewhere about through here. It may be a little bit skinnier, okay? But we get the general idea of the graph. This would be one because of these intercepts. You wouldn't actually have to graph this, but it would be multiple choice probably, okay? All right, then finally to state the domain and range, the domain is still negative infinity to positive infinity. The range we can, because it has a turning point at the bottom, because it opens up, my vertex is a minimum, it is going to have a starting point on the range of -7, and it's going to go to positive infinity. Yay! All right, so the nice thing is that if I go too fast, you can pause it and go back to the problems that I've gone so fast through that you need to go back and take notes. So feel free to pause me. All right, for the quadratic function x squared minus 8x, this one's a little different. It doesn't have a plus anything at the end. That's okay. We can still find the vertex. We're still going to use h is equal to -b over 2a. This one I'm going to be careful with because I messed up the last one. Negative b, in this case, let's go ahead and put in here, a is 1 and b is -8. So this is going to be the opposite of -8 divided by 2 times 1. So it is going to be a positive 8 over 2. So we're going to have a positive 4. So the vertex is going to be 4 something. Now to find that second part, we are going to find f of 4. And f of 4 is going to be 4 squared minus 8 times 4. So we have 16 minus 32. You could probably guess by the numbers here, this is going to be -16. Yes, I know. I've kind of contrived my graphs so that they're nice. All right, so that's going to be my vertex. Does it open up or down? The value of a is +1. We've actually already established that here. So it's going to open up. All right. The axis of symmetry, you're pros at this now. It's the equation x is equal to, correct, 4. The x-intercepts, so we're going to take the function x squared minus 8x, and we're going to set it equal to 0. How do we solve this? We still factor, and we factor a greatest common factor of x out. So x will factor out, leaving me with an x minus 8. So I set each factor equal to 0, so I get a 0 at 0, and I get a 0 at x is equal to 8. Now, if we write these as ordered pairs, 0, 0, and 8, 0, does anybody know what the y-intercept is? You got it. It is at 0, 0. So if you don't remember that, or you're like, I don't know why, then that's okay. We can still plug 0 in for x. And look what happens. We get 0. So our y-intercept is at 0, 0. Yeah, some of you already knew that. It's okay. So we're going to plot those points 0, 0, 8, 0, and way down here at 4, -16. Now you just thought my graphs were bad before. Now it's probably going to look even worse because I've got so far to go. Down here, turn around, and go up close enough. All right. There's my graph. Domain and range. Domain is still -infinity to positive infinity. And my range, yes, we have a turning point on the bottom, so it's going to start with -16 and go to positive infinity. Okay? Excellent work, guys. We are almost done with this. Now, the next one says, without graphing the quadratic function, let's see what we can determine about it. And you probably know more than you think you do. So the first question says, does it have a maximum or a minimum? So it's not coming right out and telling me what to do. It's making me think just a little bit. How do we know if it has a maximum or a minimum? Well, we need to know where the turning point is. So how do we determine where the turning point is? We determine which direction it opens. So this question first says, where does it open? How does it open? So the first thing we want to do is say, okay, a is equal to -1. And this means that the graph of the function opens, yes, you got it, down. Okay, because it opens down, then the second thing we need to think of is if it opens down, then that means that the vertex is on the top and the vertex is a, yep, it is a maximum. And that's it. Okay? So you got this part, so it's a maximum. Then it says find the maximum, so we don't need the minimum value, we just need the maximum value, and where it occurs. Now this is the y part of the vertex, and this is the x part of the vertex. So that means we need to, you got it, find the vertex. So we're going to find the vertex. So the vertex for this problem is going to be h is equal to negative b, which is negative 4, over 2a, which is negative 1. So it's going to be a positive 4 over a negative 2. So we're going to have a negative 2 for the x part of the vertex. The k part of the vertex, we're going to plug negative 2 in. So f of negative 2. Now watch out on this one. Negative, and then negative 2 squared minus 4 times negative 2 plus 8. This negative gets squared. This one does not. So this is negative 4 plus 8 plus 8. So I have 4 plus 8, or a y value of 12. So the maximum value is 12, which occurs at x is equal negative 2. Okay, so be careful and make sure you answer the question in the right order. Now the last part of this says identify the domain and range. Okay, so domain, we're kind of getting used to this one, negative to positive infinity. Range, because my function has a maximum, yeah, that means it does this, it goes like this, we don't care which way, okay? That's a bad graph, but anyway, it goes like this. So that means my range has a stopping point. You got it. So the range goes from negative infinity to 12, and we're going to square that off. Okay? I'm going to erase that because that's a bad graph. Okay, I know it was on the other part, but it's all right. All right, last but certainly not least, same directions without graphing this quadratic function. Let's find out what we can about it. So does it have a maximum or a minimum? Yeah, I know some of you are answering me already. So A has a value of 2, which means that it opens up. You got it. And if it opens up, then that means it has a, it has a minimum. Okay, so since it has a minimum, so that's going to be important there. Now we need to find the minimum value, that's the y part, and determine where it occurs, that's the x part of my vertex. So that means we need to find the vertex. So the vertex is, once again, negative b over 2a. So it's the opposite of negative 8 over 2 times 2. So I'm going to have a positive 8 over 4. Or I'm going to have an x value of 2, right? So it occurs at x is equal to 2. We can even write it like that. The k part of my vertex, I'm going to plug 2 in for x. I have 2 times, oops, I skipped a step there. My brain got ahead of me. 2 times 2 squared minus 8 times 2 minus 3. So this is going to be 8 minus 16 minus 3. Negative 8 minus 3 is going to give me a value of negative 11. Okay, so this means that the, you guessed it, the minimum value is negative 11. Excellent. And it occurs at x is equal to. Excellent. Domain is still, I told y'all you were going to get tired of domain. Range, however, I want to think about a little bit more closely. We have a minimum value. That means the turning point is on the bottom of the graph. And so our range is going to go from that k value to positive infinity. I hope you have enjoyed Chapter 4, Section 1, all about quadratic functions. In the next chapter we're going to start is Chapter 5. That will be the next set of videos. And Chapter 5 has to do with exponential functions and logarithmic functions and all kinds of fun things to look forward to. So, waiting with great anticipation. we will stop here, section 4.1. Have a great day.